Hi, my name's Jane Quicke and today we're going to be making cheese. A brief introduction about me. I'm from a dairy farm in southwest England that makes a traditional cloth-bound cheddar called Quicks, and I'm the 15th generation to come and work on the farm. So today we're going to be making mozzarella, and I'll take you through how to make it, and we'll talk a bit about cheese and cheese making as we go along. We've got our equipment here, which you should have in a list. Just to say, the one thing I would say is very much optional here is the pH meter. So I filled up my saucepan with water, but I haven't put the heat on yet. And I'm just going to put, so what I like to do is put a steamer inside. Oops, sorry, a bit of a clang there. Really that's just so that you have more control over the temperature of the milk. I'm then going to add a litre of milk to the bowl. So for making mozzarella, it's useful to have unhomogenized milk, and that's because of the way that homogenization changes the interaction between fat and protein in the milk. We also make cheese with milk from other animals such as goats and sheep, and something you might have noticed about goat's milk cheese is that it's much lighter in colour, and that's because cows can't digest a pigment that's found in grass called beta-carotene. It's also found, the orange pigment also found in carrots, for example, but goats can digest that pigment, so it breaks down and it doesn't produce that kind of yellowy colour in the cheese. So next we have the citric acid, and that acidifies the milk and lowers the pH. When the pH is lowered, the casein, which is the protein in the milk, changes its charge such that it clumps together and coagulates, it also creates, so the acid also creates a more optimum environment, optimum pH for the enzyme rennet, and the kind of scientific name for rennet is chymosin. We're going to be mixing half a teaspoon of citric acid with 60 millilitres of warm water, and we're going to prepare that in advance, but we're just going to leave it then while we heat the milk. To make sure your milk is around 13 degrees, or at least 13 degrees, before you add the citric acid. I'm then going to heat the milk to 30 degrees C, stirring gently, and you should start to see the milk curdle. Raising the temperature to 30 degrees C is it creates a slightly more favourable temperature for the enzyme chymosin to work. Chymosin's optimum temperature is actually around 42.5 degrees, but it's helping it out a bit, so it will mean that the action of the enzyme is a bit faster. So while we're here, we might as well talk about other ways of acidifying milk. So another way that is often used in cheese making, such as cheddar, is the use of bacteria such as lactobacillus casei and other strains of lactobacillus bacteria. And what they do is they convert the lactose, the sugar in the milk, into lactic acid, which acidifies the milk. So as soon as the milk gets to 30 degrees, we're going to want to take it off the heat and remove it from the saucepan with the water in, and that's because if we leave it there, the temperature of the milk will continue to rise. On the top of the milk here, you can see the non-homogenized milk fat. And today in this recipe, we're also going to be using rennet. And what rennet does is it cuts the protein, which enables it to form an even tighter coagulation. Now we're going to add the rennet, and we're going to stir for 30 seconds, and then we're going to leave it for 10 minutes. It's important not to stir for longer than 30 seconds because it will disrupt the action of the rennet. And there are other ways to coagulate milk. So we can just use acid and heat, or there are even some cheeses that use a method of coagulation where they use a plant in the thistle family called cardoons. And so there are some mainly Portuguese and Spanish sheep's milk cheeses, and it gives the cheese an incredible flavour. So once the curd has had the opportunity to separate from the whey, we're going to ladle the curd into a bowl with a sieve, and we're going to do that with a slotted spoon, whoops, like this. So we now have the curds separated from the whey, and we're going to add the salt to the whey, and we're going to heat it to 80 degrees C, and it's going to act as our stretching bath for the curd. We've let our curd drain a bit in the sieve. Here I've torn my curd into 3 pieces, which will become my mozzarella balls. The whey is going to be really hot, so it's really important to wear gloves. Mine are bright pink, yours don't have to be, just a preference. Good idea to have some cool whey ready to put the formed mozzarella balls in. The whey is now at 80 degrees. I'm going to take one of our pieces of curd. I'm just going to dip it into the hot whey. And what we're trying to do here is get the curd right through to the centre to get up to that 80 degrees. So we just want to lightly press it so that we can see how it's doing in terms of stretchiness. We want to be really careful we don't crack the curd, so we're not going to try and stretch it before we know it's very much ready and warm enough all the way through. So we don't want to break the structure of the curd. We very much want to stretch it rather than break it. And you might not want to overwork the curd too much, and what will happen if you overwork it is it will become tough. So you can see here the curd is really stretchy, and at this point you can wrap it into a ball. So I've wrapped it into a ball, and then I'm going to just use one finger to push in, and then I'm going to wrap around the rest of the curd into a ball, and then just tuck the underneath bit in and pinch it to form my mozzarella ball, like so, and then pinch at the bottom, popped it down into the whey, and now I'm going to do the exact same process with these other 2 pieces of curd. And here we have the final product. All we need now are some tomatoes.